Today I'm gonna explain this problem about an engine system shown. In this problem we have to look for the angular velocity of the connecting rod BD. This is the draw of the engine system. This is B and this is D. So we also have to look for the velocity of the piston P. As you can see, this is the piston P. And so we have to check the list of the data that the problem provides you. So first, we have 2000 Rbm. We have the size of the rod AB is 3 inches, and the point BD is 8 inches. So first we have to analyze the draw and the movement that we are looking for and the movement that the engine system is doing. So first we have the movement, what is a rotational movement, and we look at the moment that the engine system is functioning. So we can see how these two are rotational and translational, and also a general plane motion at the moment that we look to the draw of this system. As you can see, the piston will have a lot of space to do the movement in a line. And so we have to analyze all these jobs to know how exactly we are looking for and how exactly we will do to the next step.
For mention, this is a complex system. We have different motions here. So the best way to calculate this is cutting in sections. So as we have more data just right here in this section, we will use this section. And in applying this section, we can extend the line just right here, which is the arm, the line of the arm, in order to calculate this second arm or this crank. If we extend the line just right here, we can draw an angle just right here. We can create a parallel line, which is equal. This angle will be equal as this angle of 40 degrees. And if we have in mind that here we have like this, like in this part, it will be created at 90 degrees or a straight angle. And we want to get this other angle, only 50 degrees. So in that way, and this will be the angle that this part will have. So now applying a conversion, we can get that the 2000 revolutions per minute will be converted to 209.5 radians per second. Now, in order to get the velocity, the final velocity in this part will be applying this formula, AB as a product with the angular velocity of AB of this arm, we will be substituting, applying all the values, we get this 623.8 inches per second in 50 degrees. And then we can get that with this volume, we will create like a kind of triangle, just right here, an obtuse triangle, using this length and this length, which is 3 inches and 8 inches. And with this angle, we can apply a sin line and sin laws. And applying the sin line and substituting the values, we can get that sin of 48 and 3. Applying, we get that our angle beta is 13.95 degrees.
Now, to continue the calculation of this exercise, we're going to look for the kind of movement that the rod BD has. In this case, the movement of the rod BD is a general plane motion because it's not neither a translational motion or a rotational motion. So, it's a general plane motion. By looking for the book, we can say the general plane motion can be seen as the sum of the translational motion and the rotational motion. So for doing this, we can see that we have two velocities in this general plane motion, the velocity B and the velocity D. Therefore, we can see that the translational motion in the point D, in this case in a translational motion, acceleration is going to be the same as the velocity v. And in the rotational motion, we can see this new velocity of the rod dv, in this case dv, that we have this angle beta that we just calculate, and this kind of angle because it's a 90 straight angle. Now, if this velocity can see as the sum of the translation of the rotational motion, we can draw a triangle because it's like a sum of vectors. In this case, this vector, the velocity v and the velocity dv, is going to be equal to the velocity v. With all this, we draw a triangle with these angles because this angle, it is the angle that we just get here. This other angle is the angle that we got here, and because a triangle has 180 degrees, we can say that this angle is going to be 53.9. Now, using again sine law, we can look for the values of VD and VDB. VDB is going to be useful for calculating after the angular velocity. Now, we use sine law to calculate VD and VDB. In this case, we substitute VD in the sine law, and we are going to get that the value of the velocity in D is going to be 43.6 feet per second. We do the same for calculating VDB. We obtain this value. This value is the linear velocity in this point, and we're going to use this formula. And we're going to get that the linear velocity is the length per the angular velocity. Substituting, we got that the angular velocity is going to be this value. Why is it going to be this value? Because it's going to be the angular velocity in this point, and in this point is going to be the answer. This is going to be the answer for the second question, and this for the first question.
Other way to get the same solution as the last one is to calculate the instantaneous center of motion. This is kind of simple. What do we have? We have the point V right here. This one is the vector or the crank that is directly connected to the piston. This one is the piston. These both are vectors. This vector comes right here. And if we draw perpendicular lines to the vectors, we are going to get this. This is the perpendicular to the vector B, D, and this one is the perpendicular to the vector of the piston. Then we are going to find the angles that we have in this shape. The problem gave us the angle of 40, that is this one. And we can move this angle wherever we want. In this case, we are going to move it right here, and this will divide this triangle, that is 40. Other angle that we have already calculated is the angle alpha. It is this one. And this one, for alternate interior angles, will be drawn here. We are going to calculate this angle. These both, as we know, and as we can see, are 90 degrees. If we subtract 13.95 to 90, we are going to get that this angle is 76.05 degrees. And if we subtract 40 to 90, we are going to get that this angle is 50 degrees. And don't forget that this one is the instantaneous center of motion. And if we write the calculations, we are going to get that this angle, the angle B, is 40 plus 15.95 is 53.95. That is this one. The angle D is 90 minus 13.95, that is 76.05, that is located right here, and the angle C is this one. This is the point C.
When we got these results, these angles, we're going to use this in order to solve this problem. And we're going to use Sin's law, as we already know this formula and this formula. And we're going to use the same with this result. We already know this distance, that is 8 inches, and this distance here is the same distance here. Knowing this, we're going to go to this part. We're going to substitute the result from the segment BC and divided by this amount, and CD divided by this amount. And nowadays we're going to solve in BC, that is equal to 10.14 inches. Right? We're going to do this process with CD now. And in the same way, CD is equal to this amount divided by this amount is equal to 8.44 inches, right? And now we already have those distances that we're going to use in order to solve the angular movement that is here. But something important is that we already know this reduced amount that is equal to 628.3 inches per second. That this is linear motion or linear movement that we already got from the last part, right? And now we're going to substitute that result in this problem, and it's going to be equal to that. And now we're going to solve an angular movement from BD that is equal to this amount divided by this amount is equal to that. And we already know the result that is 61.962 radians per second. Well, we already got the first result, and now we're going to get the second result that is linear movement from D, right? So as we know, linear movement is equal to CD by angular movement. And we already know the angular movement we already got. So we're just going to substitute these results in this formula that is going to be equal 3D multiplied by 8.44 inches that we already got here with Sin's law, and multiplied by 62 radians per second. Why 62? Because we close this number with an entire number. That's why it's 62. And now knowing this, we're going to solve for this, and we're going to get that linear movement is equal to 523 inches per second, and that is equal to 43.6 feet per second. And that's it. This is the last way to solve this problem. Thank you for watching, and I hope you learned from this exercise. Thank you.